All right, good morning and welcome to Jamesway's webinar Wednesdays. As you can see, I'm joined by Philip this week, and Philip is calling in remotely, so everyone will have to let us know if you have any issues with how this is going to work out, since this is our first time broadcasting this way to everyone. In case there is anyone new here, your control panel is in the upper left corner of your screen. There's a raise hand button. You can use that if you need to get our attention quickly. The Q&A button is where I'd like you to enter any questions you may have for us. Those will come direct to me right here on the computer so I can see what you're asking, and we'll get to everyone's questions as best we can. Then there's a chat section. You can use that to chat either just to us, the panelists, or you can also chat amongst all of you if you'd like. Just as a disclaimer, when you do that, your full name will show up. And then finally there's an audio and video options section you can use if you're having any problems with the feed that's coming in right now. On that note, today's topic is biosecurity in your hatchery. We all know that biosecurity has been really thrust to the forefront based on the number of recalls and outbreaks that have happened in hatcheries in recent years, both with salmonella issues and avian influenza. And so today we just want to give you a bit of an overview of the important points in terms of hatchery biosecurity and hopefully foster some good discussions. I do want to say that we here at Jamesway are not chemical companies. We are not sanitation specialists. So we will not be advising on any specific kind of chemicals to be used in your hatchery. You guys are free to mention in the chat to each other what you guys are using and what you're finding is working. But we here at Jamesway don't have any specific recommendations in terms of a named brand product to use. With that, I think we'll go ahead and throw up the presentation and get started. So, as an overview, we're just going to go over the main poultry infectious diseases, the modes of transmission that we generally see, avian influenza and the vectors of introduction into a poultry flock that exist. For those of you in the US, I know you'll be very familiar with this, but those of you internationally, you may not have seen as much on the 2014-2015 high pathogenic avian influenza outbreak in the US. We're going to go over some of the major findings and causes there, and then just some general biosecurity that you should be considering in your hatchery. So in terms of poultry infectious diseases, salmonella, we all know, is the big concern. It's the one that all the consumers really are familiar with. We've had, these are US stats, but since the 90s, 45 salmonella outbreaks have been linked to live poultry. Other concerns, of course, would be avian influenza, big in the news right now. In terms of avian influenza, it's just like the human flu. We have a lot of different strains. There are different levels of severity and different modes of transmission. So not all avian flus are going to be as dangerous to both the birds and humans the way that the high pathogenics are. Other bacteria we have of concerns, E. coli, everyone is familiar with that, usually from drinking water issues. Mycoplasma species as well. In terms of poultry health, we have concerns around viruses like Marek's and Newcastle. Parasites are also a concern, coccidia, and then fungi such as aspergillosis, which causes brooder pneumonia. In terms of modes of transmission, there are a lot of different ways that bacteria, viruses, fungi can be introduced into a hatchery. The first way that we look at is through vermin, through rats, through mice, etc. It can also come in airborne, whether that is through your ventilation system or being spread throughout the hatchery as a result of banger eggs. There's inadvertent modes of transmission coming in on humans or workers, coming in on machines, coming in on equipment and vehicles. Access to feral poultry and other feral birds. In terms of AI, waterfowl, migratory waterfowl is a large area of concern because waterfowl are asymptomatic carriers of those diseases. Through the water, not such a large concern as water is generally treated in most areas. Through waste and proper waste disposal. And then there's also a case of vertical transmission, so disease would be passed down from the mother hen to the eggs and thereby to the chicks. So this little poster, this sort of shows how prevalent the concern on AI is. This was actually something made up to be posted in primary schools, so your grade 1 to grade 6 children, for them to be aware of the AI risk that there is. So there are two general types. The first one is the high pathogenic, and the second is the low pathogenic. The difference there is essentially on how severe it is. A high pathogenic influenza, whether it's avian or human, is going to have a high mortality rate. There also would say things like it's going to be killing, young adults who are generally healthy, not just children and the elderly and those who are immunocompromised. A low pathogenic influenza then is something that you or I would get. We would be a little bit sick, but we would get over it fairly quickly and would really only pose a danger to those who are of a low immune status. AI is also geographically different. The AI seen in Asia is different than the AI strains that have been seen in North America. One positive here is that there is a low cross-species transmission, so while the birds may be infected, there is a low chance of transmission to humans and also to other species, say cats or dogs or cattle, whatever. Of course, the high pathogenic is our greatest risk to humans. In the transmission of the high pathogenic AIs H5N1 that has transmitted to human, 50% of them have died. And in these cases, the human infections have been from direct contact with live poultry, primarily. There was some familial transmission there as well, but thus far, avian influenza is not something that has spread throughout a population at large. The major vectors that we're seeing for AI, and these are the things that we need to be thinking about when we're defending our hatchery, our barns from AI. The first one and the major concern really is migratory waterfowl, particularly young birds. Your ducks, your geese, those sort of things. And what we're seeing is that it can then become airborne from an area on that migratory path. It's coming in on the boots of workers, on the wheels of vehicles that happen to be driving past lakes and ponds where these birds are congregating. And if you're drawing water off of one of these lakes or ponds, then it could be contaminating your water supply as well. So a major concern there is the movement of staff, materials, and vehicles between your farms, between your barns. The movement of poultry, even moving birds through an area that is high in waterfowl could be dangerous. And then, of course, rodents and vermin. And as mentioned, airborne from other infected sites. So what we did find in 2014 and 2015 is that the speed of depopulation or cull of those contaminated birds is key, because the longer they are there respiring and breathing out that virus, the more chance there is that it can become airborne and move and infect other sites and other poultry in the area. So in terms of that outbreak, Helen from Hybrid Turkeys said, "This is not just the largest poultry disease outbreak, it's the largest animal disease outbreak in the US, period." And that's significant, there's a lot of focus on a lot of bovine diseases, but AI is actually more significant than those. In the US, 11% of the layer population was lost, 10 million turkeys were culled, 220 farms in 15 states were affected. They're estimating the cost was over $3 billion, and it resulted in a lot of countries banning US poultry products and additional controls from even more countries. And the main causes really found there was proximity to those migratory waterfowl. The farms affected were in the migratory paths, and then inadequate biosecurity overall, farms located close together, but also transmission via people, through the trucks and through people such as potentially the serviceman from the electrical company. Not just the hatchery staff or the farm staff was considered a concern there. And as a result, egg prices in the US raised by 80%, which is a fairly significant factor, of course, and that has brought AI really to the forefront of consumer attention as well. So when we're talking about personnel, these are all the things that you need to be thinking about for anyone that's coming to your farms, to your hatcheries. So not just your employees, but also the truck drivers, also a serviceman for your HVAC or for your water systems. So first of all, you always want visitor control. That's something that everyone is well aware of. A 72-hour withdrawal from poultry. These people should be wearing protective clothing, hatchery-provided clothing. Ideally, they're going to shower in and shower out, actually use the showers, actually use the soap. Foot baths are a very minimal, simple, and highly effective way. Truck wash stations, because as mentioned, these trucks were driving past contaminated areas and bringing contamination in. Equipment sanitation, is their tool bag that's coming in clean, or is it full of down, say, from another hatchery or something like that? And then basic hand washing practices. And making sure that you encompass all of this will greatly reduce the risk that you're going to have for AI, contamination, Salmonella, E. coli, all types of biosecurity concerns. So in sanitation versus disinfection, this is one thing to get clear. Cleaning is not disinfecting, and disinfecting is not cleaning. So you can see here, especially on the green boots, they're sort of flat-bottomed. They were washed, and they still had transfer to those plates. But once they've been disinfected, we now have no transfer to our culture plates there. And that's the key. A disinfectant is not going to work if the surface is not already cleaned. There can't be large masses of dirt, because then that's blocking the disinfectant's ability to get to the surface and disinfect. So it is a two-part process. Everything must be cleaned properly and then disinfected. So I think we're going to pass it over to Philip, who's going to go over some more hatchery-specific concerns.
Okay. Well, thank you, Victoria, for that presentation. That was very, just reminding us again of the hazards of disease and what can potentially happen to your hatchery. I'd also like to mention that this the presentation you just viewed was prepared for our installers in the field. We find a lot of people with a lot of mechanical abilities who are not educated on our industry and our biosecurity measures that we use. And so we've developed this to show them the risks that are involved and why we go, and when they go to a hatchery, why a lot of these steps are in place. So this, I think that's a very good presentation for them to learn. But so I'm going to give a definition for hatchery biosecurity. It's animal biosecurity is the product of all actions undertaken by entity or a hatchery to prevent introduction of disease agents into a specific area. So we'll be taking a look at a few things. Some of this is a little bit redundancy on what Victoria just spoke, but hey, that's how we learn. So take a look at some of the bacteria that's often found within the hatchery. Pseudomonas is a main one. It causes high early mortality rate in chicks. Aspergillus, gellosis has several names, but it's a fungal infection disease, which is the typical sign is gasping for breath, especially in young chicks. Just mention my experience with Asper has always been with paper products or cardboard. Mold really likes to live on that if it gets moist, and so I just caution you to ensure that your paper products or goods received are kept dry as possible and sanitized as much as can be done. Klebsiella, baby chicks go up to 2 weeks of age are most susceptible to infection. This can be a pretty harsh on the birds and cause a lot of mortality. E. coli, Victoria mentioned a little bit about that. E. coli is a natural inhabitant of the gut in poultry. Normally it is kept in check by other bacterium, but if large colonies form, it can cause severe discomfort, illness, mortality. My understanding, E. coli is everywhere, and it got to your gut. It's just that sometimes it turns into diarrhea. Depends on the harshness. My experience as a hatchery manager, I had an incident with E. coli getting in my baby turkeys, poults, and we did not detect it was a problem until we quit injecting with gentamicin. So it was killing or a high like up to 20% mortality on one group, and the other group there wasn't anything dying. And after we traced it back to injection. The other thing that I noticed, anytime my hatchery became infected with E. coli, there was some sort of ground disturbance around the hatchery, whether an old septic system or something, I don't know, was the cause. But that's when I noticed that E. coli would crop up. Streptococcus, it's an opportunistic infection leading to acute and chronic conditions in infected birds. Again, mortality. And Staphylococcus is worldwide, have early mortality up to 15%. Infection is usually by the respiratory route. Move along here. I just want to check, since I am remotely, are you hearing me clearly and seeing the slides? Everything okay?
It's coming through fine here. Is it looking good for everyone else? Maybe want to give us a raised hand, guys?
Excuse me?
Yeah, it looks like everyone is hearing and receiving your transmission quite well, Philip.
Okay, great. I just wanted to check. So this is a new thing for us, but it's working well. So Victoria mentioned a lot of forces or vectors into the hatchery, and I mentioned paper earlier, but today I just want to focus on these 4 things that we have somewhat control over. Well, I say somewhat, but we'll get into the presentation, but we'll be taking a look at air, how it can infect a hatchery with bacteria, eggs, people, and water. So the first one we're going to look at is air being introduced. And I'm going to ask Victoria, that she is the airflow expert, to kind of go over some of these things that could possibly be introduced into your hatchery.
Yeah, thanks, Philip. So yeah, for those of you that don't know me, I used to do HVAC design and hatchery design here at Jamesway, so this is sort of my wheelhouse. There is a lot of possibility of airborne contamination in a hatchery, and that is both from the outside, from something like a migratory waterfowl route, but also on the inside. So first of all, on the outside of the hatchery, we want to make sure we're not near any potential contamination sources. And that's being everything from feed mills and processing plants down to what is the local area, the local animal population looking like. Could they be a problem? Yeah, I saw that, Mark, that we did see a bit of a bobble there in the connection. Is it better now? Seems better from my side. Just let us know, okay? Thank you. And then also the design of the hatchery. One thing you always want to focus on a hatchery is that for the prevailing wind of your area, you want that to blow from egg to chick room, from clean to dirty. That way we're not taking the exhaust air off the chick room, blowing it back into the egg room, and potentially contaminating all of our birds. In the hatchery, we're looking at the same premise, clean to dirty airflow. We want our highest room pressures, the most positive rooms, to be on your clean side in your incubator rooms, in your clean rooms. And then we want the most negative pressures to be in your dirtiest rooms. Usually the pull room is set the most negative, so that we can keep all that contamination sucked in and sucked out of that room. So that's super important. And if you do have pressure control in your hatchery, you should be going through and making sure that everything is well calibrated, everything is measuring properly. Because it's often the case we'll find a sensor was out and we thought that our incubator room was the most positive, but you know, our sensor broke in the pull room and now it's the most positive, and it's actually pushing contamination out. We want to make sure our rooms are not open to the outside. We also want to make sure our rooms are not open to other rooms. We can't maintain that good pressure flow, clean to dirty, if there are penetrations. And you want to look for small penetrations. There could be something as simple as a gap where a duct goes through into another room, and that could be actually forcing air back through, especially if your hatch room and your incubator room are connected and not separated by another room. That could be a source of contamination pushing back. Supply and return filters. You know, in your hatcher rooms, you should be cleaning those filters every hatch. And if not, what's happening is you're actually going to be collecting the contamination and putting it back through the system. Same thing, we don't want any exposed insulation because that can harbor bacteria and send it back out. You know, I've been to a hatchery that was having a problem where salmonella was just kind of cropping up all over the hatchery. And it came down to, you know, some small holes from room to room, some less cleanable materials being used here and there, and the pressure control and the pressure balance not being quite right throughout the facility. And once you get that straightened up, then you can get a good control over that. Rooftops not operating or not operating properly. You know, maybe your damper motor is stuck, so you're not maintaining pressure properly. Those are all concerns. Also in rooftop units, if it's been set and it's not perfectly level, or even if it is perfectly level, maybe the pan was a little warped when it was put in and you have water building up inside that rooftop, that can be a source of contamination. So you want to make sure that you have drains in all your rooftops. You don't want any standing water in any of those. So those are really our main concerns in terms of airborne contamination.
Right. In a lot of my service calls, the units are just associated with the filters being dirty, and then the units themselves on the just because you clean the filters doesn't necessarily the unit is clean, so it should be periodically wiped down or cleaned from the inside as well. A lot of fluff and airborne things can get pulled back through that. There's also some microbial filters that are available too to catch some of that stuff.
Yep. There's some microbial filters. I know some hatcheries have started using UV lights in their duct or in their actual rooftops, and I think that's even an option from some of the HVAC companies to have sort of a UV section built into your unit, which can sanitize the air. So there's lots of opportunities and there's lots of technologies out there that can help on those sort of things.
Right. Thank you. The next source is, which I said earlier that we have control over. Unfortunately, sometimes with eggs, we don't have as much control over those coming into our hatchery as what the farms or our supplier are sending us. Dirty eggs, I see this all the time. Floor eggs, dirty nest material, cracks. All these are sources for the egg to be contaminated and cause an outbreak of either bacteria or they're just dirty. Here's a slide that you've probably seen in some other presentations, but a freshly laid egg has about 300 bacteria count. A clean egg has 3,000. Soiled up to 26,000. I can see just a little dirt on that one, and then very dirty 400,000. Unfortunately, I see very dirty eggs at a lot of hatcheries I visit. They're trying to slide those through. I was talking to a manager the other day, and he actually brought some of the farm workers in and showed them the effects of dirty eggs, the cleanliness, and then also the hatchability of them. The reports that that universities have done, they're just not worth it. They don't hatch well, and what does hatch is contaminated and usually infects your whole hatch. So yes, everybody is trying to make some money, but unfortunately it works the other way whenever those are introduced and ran through incubation. A little bit more about egg handling is the hatchery fumigation procedure. A lot of hatcheries, I don't know whether your hatchery does, they'll either fumigate with a fogger on the back of the truck before the eggs are offloaded. Some have an extensive receiving area just to fumigate the eggs to make sure that they have been, a disinfectant has been, or a sanitizer has been applied to the eggs. Poor egg room sanitation. Egg rooms are typically cool, but they also have more displacement of water that can get on the eggs, get on the racks, pools of water on the floor, all prime places for bacteria to grow. Take a look at setting procedures. Sweating eggs prior to setting into an incubator, or sweating eggs in general. One thing that I think that I always used as my reference for sweating eggs, as long as your eggs are continually warming up, the sweating is no problem. It's when they sweat and then they go back into a cold environment. When they're pushed back, then the moisture on the outer layer of the egg is sucked back in by a vacuum, because the egg's being cooler. When they're pushed back into a cold area, then that moisture will be drawn back in. Any of that bacteria, even if you had 300 parts, which we saw in the previous slide, will be potentially be drawn into the egg. So sweating is okay with me as long as I keep getting warmer and warmer and warmer with it. So it starts at the farm, comes out of a hen at about 103 degrees. It immediately is cooling down to the farm egg room, and then from there onto the truck to the hatchery. So it's just all those places. We just want to try to limit our sweating. And again, just remember, as long as you're going warmer, it's not as bad as going cold, as it will suck it back in. Broken eggs. I've visited a lot of hatcheries that have broken eggs in incubators. I don't know how long they've been there. They have cooked, but again, these are, as far as your egg handling, those spills need to be cleaned up, taken care of.
Philip, we have a question from Mark. Mark wants to know, what are you seeing being used for fogging eggs in fumigation rooms?
When?
In the fumigation room, what do you see being used for fogging eggs?
Procedure?
No, what types of chemicals?
Oh, usually a quat. I've seen quat. I've seen some other stronger chemicals used, but what I've typically seen is quaternary pneumonia. That.
Great, thank you.
People. Again, Victoria had commented on that earlier, and as being a vector for entering the hatchery. So just take just some things to just sort of just kind of get your interest in it, and things to think about is movement. When we think of movement, we think a service person been out on a farm and then comes to the hatchery, or the main office is at the hatchery, and there can be cross-contamination of movement, or people visiting multiple sites, and I know some companies have multiple hatcheries just down the road, and setting the same eggs. You have to sort of evaluate the risk and probably have your vet or one of these cleaning companies evaluate what your risks are as far as movement is concerned. The documentation is I just, about every hatchery I visit anymore, documentation of where I've been, where I was the previous week. Hatcheries require anywhere from 24 hours to 72 hours of being out of poultry before coming into their hatchery. Also, in some countries require a week out of poultry. They want you to be in their country before you go into their hatchery. So make sure you find a nice resort to stay at before you go into their hatchery. We have course training, and me being a previous hatchery manager, a lot of times it was just ignorance of people not knowing the risk that they had. And especially new employees, I know a lot of companies now have tried to allow more shadowing with new employees, which is a very good procedure. When I managed a hatchery, I always felt like it took at least 6 months for that person to be into a position where they could be allowed to do their thing. SOPs, I see these for every type of work that could be a biosecurity or risk factor. So looking back through my notes from a previous company, we had SOP for egg truck delivery, poult delivery, cleaning, how to clean the wheels, just cleaning your hatchery, a procedure for your hatch room, for application of cleaning disinfectants. And I'm sure a lot of you already have that in place, but I also know that you occasionally need to go back and just check out, make sure that the procedures are being followed. There are lots of incidences that require a one-day change that if nobody goes back and checks it, that may become the new rule that you weren't aware of and needs to be addressed. Clothing. Prefer the clothing to be worn to be maintained at the hatchery. So your outside clothing is not worn into the hatchery. Coveralls, boots, things like that to prevent any contamination being brought in. A shower is especially for primary breeding companies, that's the norm now. You will shower in, change into their clothing. And tools, things like that had to be processed if you need to bring them in. One thing that we had mentioned earlier for some of our service people come in, maybe to service your generator, rooftop units, things like that, they often are just placed in disposable coveralls because it's usually on an outside wall, and they can just hit an area that's usually not comes in contact with your birds or your eggs. Staff crossing from clean to dirty areas. A lot of times new staff doesn't know the risk of going from the washroom to the egg room without some sort of barrier or break or foot bath or hand wiping or something, just because we're in a potentially high area, contamination area. We don't want to carry that in. And then staff access to vectors of contamination. Pet birds, most companies don't allow any pet birds. Waterfowl, if you're a hunter or turkey hunting, things like that, there companies require if you do kill game to take a couple of days off or whatever's required. Spouse. I have worked with companies where a spouse couldn't work on a farm and another one work in a hatchery. If it did take place, then either something was put together so that they could both continue to work for the company, but they might have to change job responsibilities or careers so they could live together and still work in the hatchery. or work in the same field, but yet at the same place. So they would not be, they could potentially contaminate each other with anything. Water. In looking at water, looking back through my notes, researching, a lot of chemical companies and people that provide the products to disinfect and clean with say that the water supply on their agenda is typically the #1 source for potential hatchery contamination. The problem being is that the water's contaminated, it gets into your humidity systems, it sprays around your machine, it comes in contact with your eggs, comes in contact everywhere. So these are, your water should be checked regularly, especially if you're on well water. I know a lot of us have gone to city water, and I think city water is typically, monitored and in pretty good shape. They want to know what we're putting into our wastewater, but but it still needs to be routinely checked. I've also been in situations to where bacteria got into the piping and was very difficult to get out. The reservoir just kept leaking into the water supply, and so we had to flush the lines. A lot of things there. Just a couple notes. Water purification using chlorine has been accepted as a method of choice. One thing about chlorine is that it is quick kill. It kills, but if it's not getting chlorine, it doesn't kill. And then the other is the harshness of chlorine on your galvanized products and or material in your machines, things like that. It can really be very harsh and cause equipment to rust. It also breaks down the zinc in the galvanization process, which can get into your wastewater, which can get you. Someone can. I used to be notified of that, and the levels that was monitored in my wastewater was the zinc. And then, but now, my understanding again, as we both have mentioned, there are other choices, for cleaning, and we're not experts, but I'm sure your cleaning suppliers can give you some other choices for treating your water. This quote from International Hatchery Practice says, "Too much emphasis is placed on disinfectants and sanitizers and not enough on the overall approach to hygiene. The significance and importance of preparation and cleaning are often underestimated." And so really the bottom line on this, I think, is just plain old elbow grease is still required to clean. We've come a long way. Even Jamesway units, you can just about get power washing all over our equipment to clean. But they fan blades, things like that, require just plain old scrubbing with a scrub cloth or brush, and just to ensure that everything gets touched and removed. Foaming, again, is a great application for cleaning because you can see where the foam is hit, and scrubs and decomposes fecal matter, any organic matter. But again, it's just because you go in there with a power washer doesn't mean your machine is getting clean. And so a couple of things: the supervisor managers can measure the cleanliness is visibly clean. They can check constantly and have the unsatisfactory results corrected, and inspect what you expect. If you expect fecal matter to be on your hatch baskets, go look and see, if they're getting them all clean, if they're coming clean. And then also the microbial clean to monitor with swabs, air plates, measure, maintain, and improve your hygiene. I'm sure you're all aware there's a variety of testing methods available, whether you have in-house testing or whether you have an outside source come in and do the reporting. You may take it yourself in some of the areas. One thing that I always found when I got my staff to buy into it, they wanted the reports. They wanted to know what they were doing. So, and then we also had a common joke that when the lab got it, it went into the dark hole. We never knew whether we were clean. Well, we knew when we were dirty, but we never knew when we were clean because we never got that good report. So I think communication with the reporting end of it is would help your staff buy into keeping the hatchery clean, and not just be a job for them, but to try to have a goal set to get it clean. We're going to switch gears here a little bit. Just compare the single stage versus multi-stage incubation. I know a lot of you have gone to antibiotic free, and you know, some of the requirements of that, we were just looking for better ways. The single stage was kind of, when it was introduced in the 90s, it just took a lot of the industry by storm because we could clean our machines before the next set of eggs went in. But let's just take a look at a couple of comparisons. A multi-stage has multiple sets. So you're going in twice a week in chicken, once a week in turkeys, in most multi-stage incubators. And so what this, you have multiple ages of eggs in that machine, which 3 of them can be clean, 1 of them can be dirty and can affect your whole set. Single stage is 1 set, all in, all out. You might have multiple flocks, but again, it is enclosed to that 1 unit and does not run the risk of spread as multi-stage does, as you could affect even more than 6 sets if the dirty eggs are allowed to go all the way through and they're spilling their contaminants over on the clean eggs. It's normal to clean multi-stage 1 to 2 times a year with eggs present unless emptied. So a lot of you know what it takes to clean a multi-stage, just to empty out. I know a lot of logistically now we've tried to, if we have a down machine, we'll try to move eggs over and then keep a machine always available to clean and to do the maintenance on it as well. But you know, let's face it, it's usually completely clean 1 to 2 times a year, and I question that at times with the eggs present, unless they're empty. Single stage, we clean and sanitize it every 18 days with no eggs present. So once you set your eggs, they're transferred out, you have time to go in and clean it, top to bottom, sideways, horizontal, get it clean and ready for dried out and ready for the next set to go in. Greater risk of disease transmission, which we've kind of already talked on, just simply being that you have more eggs exposed to the potential risk. Eliminates the risk of disease residue. This can, by doing this, because of all the eggs in, all the eggs out, if the machine is cleaned properly, then you reduce or eliminate the risk of any disease residue. Should disease be present, multiple sets affected 3 to 6 weeks production. Should disease be present in single stage, 1 batch of eggs can be affected. So again, I just comparing single stage versus multi-stage, just wanted to take a look and just ask you which is better for biosecurity. At this point in the game, I think single stage would get the hands down for the best equipment on the market for keeping our eggs clean and not affecting other sets as they go in. I think that brings us to our close. So questions, I'll let Victoria moderate for us now.
All right. So if anyone has any questions, you can throw them in the Q&A panel. I know that was super interesting for me, and there's a lot of monitoring techniques available out there. One thing to be careful of, which your chemical supplier should be aware, is that if you are using ATP swabs and you change the type of chemicals you're using, the type of active disinfectants, you do need to be aware that some types of disinfectants will actually provide you false positive on those ATP swabs. I ran into that issue when I was working in food processing. So while they are a great little technique to use, because they give results right away, which gives gives the staff the feedback to make sure that they have done their sanitation job. You do have to watch that there are certain cleaning chemicals that will trigger that response as well and give you a false positive on that system. Just to give you all a heads up, the next two webinars are scheduled for January and February. As you may have seen, Dr. Keith Bramwell has joined Jamesway recently as of the end of October. And he's going to be doing a two-part mini-series on the embryo. The first webinar will be in January 24th, I believe, and that is on embryo diagnosis. And then the second one is on the development of the embryo. So really going to give you some tools from the embryology side on hatchery management and analyzing issues in your hatch. So those are up live now. You can go and register right away, jamesway.com/webinar-Wednesday.